Jai Hind all. Myself Amita Asthana from Ajay Kumar Garg Engineering College, Ghaziabad. Here in this video lecture, we will take the topic from Digital System Design, the syllabus prescribed by AKGEC, Lucknow, the code KEC 302. The Unit 5 topic we are going to discuss, that is DAC, that stands for Digital to Analog Conversion. So here the digital to analog conversion in this, whatever the input digital stream will be given to the DAC, the output is the analog value. So here we will see how the digital values or digital data are converted in analog values. So here there are the contents for this video lecture. First is introduction to digital to analog conversion, and then types of D to A converters. In this we will discuss two types of DACs. Here now let us start with the digital to analog conversion, that converts a digital signal into analog. That is, here let's say we have given some digital data, that is 0, 0, 0. The analog value corresponding to this will be 0, this is 1, this is 2, this is 3, and so on. So the meaning is we need to convert this digital input signal to analog value. That means suppose this is the data stream that has to be given to DAC, and the output will be some analog value. And the formula which we will discuss, that is, see here, K is a constant, and then the output voltage value will be equal to B naught, that is LSB. Here it is LSB, and this is MSB for n-bit data, and here we can see this is 2 to the power 0, 2 to the power 1, 2 to the power 2, and so on. So the value will be calculated corresponding to the given formula. For Bn is equal to 1 or Bn is equal to 0, only there are two values for all the Bn's, because it is the digital input we are giving to the DAC. So this formula has to be remembered all the time. This is important for as far as the DACs are concerned. Now there are two types of DACs, and the DACs are employing basically the circuit including switches, resistors, op-amps, etc. Also one more important component that is used for DAC is resistors. So here there are two types of resistor arrangements which we are going to use. First is binary weighted resistor, and second one is R to R. So here we will take some resistances like R square, R cube. So many resistances we are required to take. But in this we will take only two types of resistances. First is R, and second one will be the 2R. Okay. So here this kind of is known as binary weighted, and second one is the R2R ladder. So first we will discuss the binary weighted resistor, and then we will go to R2R ladder. So here now weighted resistor DAC. So it is a kind of summing amplifier. So we are using the op-amp circuit IC741 we will be using. Here we can see one op-amp circuit is there, and we have taken inverting op-amp. Here is the feedback resistance RF, and for this the value of VO will be minus RF upon R1. Now how this R is needed to be calculated, this we will see. Here the input current is going on, and the most important point which we need to take care of, that at the upper side where the resistance R is being taken, here it will be the MSP of the digital data, and at the bottom there will be the LSB, and the power of the R will be 2 raised to the power n minus 1 into R. So these 2 points are very important. So if you remember these type of arrangement, then the other calculation becomes easy. And here see, VO and V1 are like, this is, suppose this is plus 5 volt and this is somehow to be 0 volt. So these are representing the 0 bit binary and 1 bit binary. So we will give input via these 2 lines, and all the switches, maybe they can be on 0 and 1. 0 and 1 switches will be moved on the position according to the digital data, and whatever be the input that will go to this op-amp, this will be amplified further, giving the analog corresponding analog value. So this is how we deal with this weighted resistance. See here, why we are calling it as weighted resistance, because R, 2R, 4R, these are the 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4. These are the weights for the resistances, same value R. So we call this circuit as weighted resistor. So the first part is the op-amp circuit. Second part is the R2R, 4R weighted resistance circuit, and then the input voltages. And for the second part, we need to remember LSB is at the bottom and the resistance is having the highest value, and MSB is at the top and the resistance is having only R value. So this point needs to be taken care of all the time. Now we can see the input current II. So we can apply the Kirchhoff current law, and all the currents, see here, I0, In minus 1, all the currents that are going to be added to give the value of the input current to the op-amp circuit. So here we can write II is equal to In minus 1 up to I0. Okay, this is the expression, and all the currents, see this In minus 1, suppose this MSB is connected, so that will be V1 upon R. Okay, so here it will be V1 upon R. Suppose this is MSB, so it will be V1 upon 2R. So similarly, all the corresponding values are being added, and we can, if we put the value of Bn and Bn to be 1 or 0, that all the values will be written here, and we can get the analog output in this way. So all the currents, if we have all the currents, then we can have the corresponding output voltage by simple calculation for the output voltage, as the op-amp rules are known. Okay, so all these digitally controlled electronic switches, they are controlled by the values V0 and V1. So here this is the formula which we can write. We can substitute the voltages for this one, and we can calculate the input current, and hence we can calculate the output voltage for the given circuit. So here this is the weighted resistor DAC. Now the advantages, the simple construction is there. The only disadvantage is we need to use so many resistance values like R, 2R. If the R value is 1 ohm, so we are required with 1, 2 and 4 ohms, then 8 ohms and so on. If we are taking like the 12 bit DAC, then we need to take large values of resistances. This is the disadvantage of this weighted resistor DAC. And also one advantage is for DAC is that it does a fast conversion. That is the only advantage for the DAC. Now coming to the next type of digital to analog converter, that is R to R ladder. Here the disadvantage of using so many types of resistances, we have removed only two resistor values we are using. First is R and another one is 2R. Now the arrangement will be same. All the RF, all the circuits of R to R will be connected to this particular amplifier, that is op-amp amplifier we are using, and then all the corresponding ground VR, ground VR, ground VR, ground VR, ground VR are connected to the 2R resistances here. So number one, so switches are connected via 2R resistances, and then in the mid of these 2R we are having all the R resistances. So this is one that we need to remember. So this is a one particular arrangement for R to R, and this arrangement is going to be repeated like this. Okay, and this R to R, but before that 3 2R resistances we need to learn, or that is 2R here, 2R here, and 2R here. We can learn in this way also, right? So here these 3 2Rs at the extreme corners and 1 2R resistance here, and then we can make the circuit by using simple op-amp circuit. Now the switch position may be on 0, may be on 1, corresponding to the bit which has been given to the circuit for the R to R ladder DAC. Now the voltage, how to calculate the output voltage, let us see. So here R to R ladder DAC for 3 bits. Suppose we have made a 3-bit R to R ladder. So how to make it? Just we are having this R to R at the extreme 2R and 2R. See here, 2R, 2R and 2R. Okay. Now this is R to R and this is R to R like this. Okay. So we have 3 bits. Since 0, 0, 1. So see, MSB is here. So that is 0. That is 0 and it is 1. Right. So 0, 0, 1 is the MSB 0, then 0 and then LSB. So here we have made the circuit for this 3-bit DAC. Input voltages switches have been already connected. Now how to calculate the values? Let us see. Now, leaving this 2R, what we will do, we will see the input resistance like this. We will see the input resistance like this, and then we will see the input resistance like this, since we are having 3 bits, right? So here, now the calculations. So we have to calculate the resistance from the circuit, that is the resistances for the given circuit, right? Okay, so let us calculate. So we will start from here. We will start from here. So there is a 2R and 2R. These two 2Rs are in parallel. So we can write it as VR by 2R. So between X and X dash. So the resistances are and the voltage is VR by 2, right? Now, similarly here, see X and X dash. Okay. So X and X dash, the resistances are, the voltage is VR by 2. Now we will open for Y and Y dash. For opening Y and Y dash, again, what we will do? So the 2R and 2R, again these 2R and 2R will be in picture, and the resistance will be R again for in Y and Y dash, and here this VR by 2 will be divided once more, that is VR by 2 square. Okay. So my circuit has been converted in this way. Again, this is 2R, these two are in series and this is in parallel. So 2R and 2R, again they will give in parallel combination, that is that is R, and 2R and 2R parallel will give me R, and then VR by 2 square will again be divided, and hence I am getting the VR by 2 raised to the power cube. Now the circuit simplifies to this particular part, and when my circuit simplifies to this, all the calculations are now easy. So up to this point, this Z to Z dash, we have got the circuit like VR by 2 cube upon VR by 2 cube with series resistance R. So this is my Z to Z dash. Now I need to calculate the output voltage. So I have VR by 2 cube for the LSB, VR by 2 square 3R, VR by 2 3R in this way. So how I am getting 3R? Because this R and 2R are in series. Now all these 3R according to the bit circuit LSB to MSB, I will write RF upon 3R, RF upon 3R, RF upon 3R, VR by 2 cube B0, VR by 2 square B1, VR by 2 into B2, and hence I can calculate the output voltage like this. Because this is inverting amplifier, the output will be V0 is equal to minus RF upon input resistance, whatever way we are writing it, the R, and then the input voltage like this. Okay. So in this way we can calculate the R2R ladder DAC. The advantages and the disadvantages. Advantages are only two resistance values we are using, R and 2R, and disadvantages are the speed is very less in the case of DAC. Thank you.